Okay, it is 9:30 here in Austin, so let's begin. Thank you everyone for attending. I really appreciate it, and I really hope you get what you want out of this. So ask as many questions as you can in the chat, but let's begin. As industrial organizations look ahead to 2026, many are reevaluating how efficient their operations truly perform. Aging HMI and SCADA systems, siloed data, and inflexible architecture often limit visibility, slow decision-making, and make scaling harder than it should be. And in today's industrial environment, efficiency is not achieved through small fixes. It requires a more adaptable, more intelligent platform built from how operations actually run. In today's session, we'll start with what is new in ADISRA SmartView version 4.1.5.0, and why these enhancements matter to productivity, scalability, and reuse. We will then walk through practical capabilities like reusable templates, symbols, secure database connectivity, rule-based intelligence, scalable architectures, and advanced visualization, each focus on reducing engineering time and improving consistency across projects. Throughout the webinar, we'll be monitoring the chat, as I mentioned before, so we can answer your questions as they come up. Please feel free to submit questions or comment at any time. We really want to hear from you. My name is Marcia Gabois, and I have the privilege of serving as the president and general manager of ADISRA. Over the years, I've worked across many areas of the software industry, from artificial intelligence to industrial automation, and previously led Indusoft through its acquisition by Invensys. Today, I will be your moderator of this session and briefly setting the stage with a couple of key slides. Now, it is my pleasure to introduce the person leading today's presentation and demonstration, Leandro. Leandro is a partner at ADISRA and leads customer application and services. He brings over 19 years of hands-on experience in industrial automation and deep expertise in HMI and SCADA systems, databases, web technology, and system communications. Before ADISRA, Leandro spent 13 years as the owner and partner at 5 Systems, delivering automation projects across oil and gas, energy, water and wastewater, agriculture, machine building environment. He also previously worked as an engineer at Indusoft. Leandro brings real-world practical experience to today's demo, exactly the perspective that this session needs. For decades, industrial automation has generated an enormous amount of data, but very little of it has actually helped people make better decisions. Large enterprises solve this with layers of software, customer integration, and teams of specialists. But small and mid-market manufacturers, municipalities, OEMs, machine builders, and system integrators were largely left behind, even though the operational challenges they face are just as real. ADISRA was built to close that gap. We are redefining industrial automation by transforming raw operational data into intelligence, insights, and foresights, so smaller organizations can operate with the same clarity, agility, and resilience once reserved for large enterprises. Our platform unifies intelligence across the edge, operations, and analytics, allowing teams to move beyond basic visualization into confident, data-driven decision-making without enterprise-level complexity, cost, or staffing. At its core, ADISRA is about making industrial intelligence practical to deploy, practical to trust, and practical to scale. Once we understood the problem, the question became, how do you deliver industrial intelligence in a way that is practical, scalable for the mid-market customers? Our answer was not a single monolithic product, but a layered platform delivered through 3 tightly connected solutions, which can also work independently or with other vendors out there. At the foundation is ADISRA SmartView. ADISRA SmartView transforms HMI and SCADA system from passive displays into intelligent operational platforms where data is generated, context is established, and decisions are made. Building on that foundation is SmartView, which turns operational data into measurable performance improvements through OEE, 6 major losses, energy management, and analytics, without the overhead of enterprise MES systems. And at the top is SmartView, our predictive intelligence layer, delivering explainable, predictable maintenance so teams can prevent failures rather than to react to them. Each product, as I mentioned before, can stand on its own, but together they form a cohesive journey for the customer in controlling both the insight to foresight to control, to insight to foresight to allow customers to start where they are and scale intelligently over time. This slide shows how intelligence is intentionally built across the ADISRA platforms. At the foundation, as we mentioned before, is ADISRA SmartView, delivering edge analytics, HMI analytics, control room intelligence, where machines run and operate, make decisions. This is a layer that understands operating states, conditions, events, and not just the raw signals. On top of that is SmartView, aggregate data across machine, line, sites to deliver OEE, 6 major losses, analysis, and energy intelligence, moving teams from visibility to performance understanding. And at the top, as I mentioned before, is SmartView, applying advanced analytics and machine learning to detect emerging failure patterns and enable proactive maintenance. The layered model mirrors the customer's digital journey, progressive, practical, and free from forced enterprise complexity. Now let's focus on ADISRA SmartView. ADISRA SmartView allows you to design applications in a single integrated development environment with a built-in AI expert system and deploy them across multiple platforms, whether it is Windows or Linux. That includes all modern Microsoft operating systems, and as I mentioned, many variants of Linux out there, supporting everything from HMI control rooms to headless edges to IIoT deployment. Efficiency comes from reuse, consistency, and flexibility built in from day one. Traditionally, HMI and SCADA systems have been passive, showing operators what's happening, but not helping them understand what is to do next. ADISRA SmartView changes that by redefining HMI SCADA as an intelligent industrial platform. It combines visualization, controls, embedded intelligence in a single solution, deploying across edge and all kinds of devices that we mentioned before. So intelligence lives directly within the application. So operators receive context, guidance, and logic where decisions are made. Some of the competitive advantages to ADISRA SmartView is first, its runtime configuration and templating. I think that Leandra will show you how that works. ADISRA SmartView allows system to be configured and updated without re-entering the development environment, reducing deployment time, simplifying updates, and lowering lifecycle costs, especially for OEMs and system integrators. Another key differentiation is the rule-based expert system. It's a built-in intelligence. Intelligence is embedded directly in the HMI and SCADA layer. Decisions are explainable, traceable, and trusted without requiring external AI tools or data science teams. Another key differentiation is our evolution to adding more intelligence to ADISRA SmartView by adding machine learning. Machine learning on its own is, as people will often say, can hallucinate. And because it learns what it learns, so the data, as data comes in, it will learn it, and sometimes that can cause hallucination. With the expert system built in, it's the guardrails to the intelligence. So now when data comes in, it can learn based on the rules saying, oh, no, that's a valid data point, that's not. So that's the guardrails, and it helps to break down the hallucinations that come with machine learning. And finally, ADISRA scalable design. Template reuse and embedded intelligence enables repeated solutions, fast delivery, and stronger margins. And it can be deployed on devices, cloud, all the way to a headless edge device or IIoT device. So now what you came to see is Leandro present ADISRA SmartView. Go ahead, Leandro. It's all yours. I will stop sharing.
Hello, everyone. I'm Leandro, and I'm going to start the demonstration of the new features. Just a second. Okay. So I'm going to start talking about the new features that we just implemented in our product on the version that was released last week. So one thing that I'd like to mention is in our help file on the release notes part, we have all the updates that we had in the past. For example, for the version 4130, these are the main features that we released, right? Also on the 4140, all right. These are the main features. And now I'm gonna present you the features from this latest version, all right? About the TwinCat driver, what was improved is the ability of connect some data types to the data types inside the PLC. For example, if we have some structures that contain structure, then inside the structure, it's highly used on the building automation, for example, that you can have rooms with lights, doors, and everything else that it could have multiple rooms and etc. For example, we can create these data types here in our product using our types. And then here on the driver structure, you can connect this structure. For example, this is our type, this is integer. In the PLC is a int, if it's an array or not, and the length in bytes that is used. With that, it's possible now on the TwinCat driver sheet, for example, here, we can just use the one tag and read the type that you created on that place is gonna be here, and then you can type this as a data type. It could be also, for example, an array. All right. So with that, with just one line, you can configure like a huge structure and read all in one block. So it improves a lot the performance. And also for the structure, when you are going to write, you can, when one tag change, you can write the whole structure or a single tag that could be a member. For example, let me show you this str structure ADISRA here, configure. It's when you create it, as you can see here, we have an array of same 100 positions, and these are the members. For example, we have a boolean, an integer, and then a structure, then the structure, and all the tags. All right. So if one of these members changes the value, it could be only this member to be written or the whole structure. All right. This is something that was improved in our product related to the TwinCat, and also here, as we released it for Linux as well, you can use the local TwinCat if you have as here. No, sorry, a TwinCat installed. You can have the routes configured. Now I don't have the PLC running, but this is a route that was created with the PLC. And otherwise, if you don't have this installed now, you can configure the route here and using the remote PLC IP and create a local AMS NetID for the SCADA PC, for example. And then on the PLC side, you create the route for the other IMS NetID. So you don't have now you don't need to have the TwinCat installed in the PC. All right. These are the main features from TwinCat that was improved. We also now released a new driver for the Siemens. Let me show you how it works. We had in the past we already have the TIA driver, but it's not a TLS communication. It was for the old firmwares, PLC firmwares. So now we have the Siemens TLS. Now this is the channel. The channel is where you configure the PLC IP if you are using user and password, for example. And then here you can create worksheets under this communication. All right, and now it's using TLS. So, oh, sorry. Oh, sorry, I didn't configure the IP, for example. Mhm. Just one moment. I think it was. Yeah. Now you can see that all the tags can be loaded using our import tags as well. So you can now also import some tags. Okay. This is a new driver. Another interesting thing that was released in related to driver was this first read delay. For example, if you have, especially for serial communication, you could have many serial Modbus devices, and in using a TCP/IP serial converter, for example, and then you want to read like each 200 milliseconds from each worksheet. This could be from one PLC, and another worksheet could be for another PLC. And all of them you want to run each 200 milliseconds. Let's talk about two seconds. It would be easier to explain that. So here you could like this one is not going to have any delay, but this one you could like start from 200 milliseconds or 500 milliseconds. So with that, all of them is going to have the same refresh time, but they are going to be delayed by 500 milliseconds. So it starts and run on second 0, and this is going to be read 500 milliseconds after. So with that, you can, how do I say, synchronize the readings, especially for serial communication that cannot allow you to use the same serial port, for example, to read multiple PLCs. So with that, you can synchronize them to avoid errors on reading. This is the main reason for this feature, all right? Another thing related here, now we have filters for the tag lists on the driver. So in this case, all of them are blocks, but you see now it could filter by tags. And also you have a possibility, let me get another one that maybe we have more tags. No? Yeah, and also you can order by tags, order by address. And this is the same tag, sorry, that word. Yeah, like here you can order by the address, by div and types if you have, so you can order by the columns. We also enhance the symbol search. If you insert a symbol here, and if you open it here and you want to just like filter by motor, it shows all the categories that contain motors, and if you go here, all the motors is gonna be okay. So this is a new improvement as well. Oh, this is a really nice feature that we have now. Now it's possible to, for example, now if you have an image like this, if you copy the image and then you paste it here, it's a huge image, so you can resize it. It's in a high resolution. And now you can directly copy and paste image from a website or for any application. Okay. We also enhanced our dynamic field control. Oh, sorry. For example, now if you are going to use a dynamic fill for this geometrical object, you can use now tag limits, but now you can use tags for it. So you can use a tag for minimum and maximum value that it was not allowed before. So this is one of the improvements. All right, this is the data watcher in one click. Click for the remote management tool. Now I have a Linux machine on this IP. Now you can see it's Ubuntu, so running the same version. I have a project already running there. All right, so now, for example, if you open a data watcher, it's gonna open connected to that machine automatically. And then if you want to get a tag, you can, sorry, for the system tags, for example, you can see the Ubuntu one, the version, everything else. So you can use the data watcher. And also we have now filters for the data watcher as well. All right. These are the improvements. As you can see, let me open here. Okay, here. One, I have a demo running there on the Ubuntu that I can access from a web page, a web browser. I can run the remote viewer as well. Test connection. I'm gonna open the screen running the default resolution. Here you can see it, but also, let me log in as administration to be able to close this window. But also, if you, as you can see here, we have the viewer here running, and we can change the resolution. Now I'm gonna put a higher resolution for the viewer, and then if I open the screen again, it opens in a new resolution. So if you are using another a smaller resolution with another aspect ratio, for example, this one, it's also possible to adjust it. Let me. So you can see it is adjusted, and all the screen is gonna use the same aspect ratio from that you set on the viewer resolution modifier. All right, it's something that's really nice. The event analysis with flexible message filtering. Sorry. You have an event object here. Now you can filter by message and also use part of the message if you want, like asterisks, and use to filter using asterisks. Either here on the configuration as using scripts, alarm event dot filter. Now you can do something like this or failure, and then you can use by scripting part of the string that you want to look in the message. Improve the trend refresh control for high-speed visibility. This is also a really nice new feature. Let me just close it, and I'm gonna run this locally, show you the difference. As you can see, maybe I'm not sure if you are going to see this improvement on the zoom, because I don't know the refresh rate, but now it's the refresh rate is 1 second for this trend. And now if you select the trend here, as you can see, the refresh time is 1 second. So I'm gonna put, for example, 200 milliseconds. Sorry. Thing. Sorry, because the cache was set, it remained the same. Okay. I disabled the cache, so I'm gonna run the viewer again. Okay. As you can see, the update rate is much faster now. So if you have values that are getting, if you're retrieving data in a faster refresh time, so you can do the same on the trained object now. So. Now I'm gonna talk about some interesting things that would be the templates and the runtime configuration, and the reusable symbols, rule-based expert system, and scalable architectures. For the template and runtime configuration, I'm gonna show you the system templates, how to insert and edit, the data types, how you can create a new template and export it. You create a screen template as well, insert these templates on the dashboard object, and also the system functions that can be used on when you create a template. All right, so now I'm going to stop this application. Now the first thing that we are going to create is a new document. I'm going to create a motor, for example. Here we have some of the members that a motor could have. So I have some here that we can an ID, a rated power KW, and all the on these members. These are the types. All right. I'm gonna. Oh, sorry. Okay. The okay. So let's use as a motor. All right. So since you have the motor on the tags, we also can create a real tag or an array of this data type. For example, we have 10 of this. Okay. So now I'm gonna use another template as a here, for example, we have this. I'm gonna delete some things. Here are the object tag that is a pointer. I don't need this one. Now I'm gonna set this as a motor. And here, oh, insert a symbol. I'm going to choose this one motor here. Right, so on the title, I'm gonna use the motor.id. Here we can use a dynamic color. For example, let's use red, the default, and motor dot is running. If it's running, like the was true, we can use like green. And also here we have a button that could open, for example, a screen of a properties of this motor. So let's save it as 01. And also we can use a screen. This is the silo property. I'm going to change this for the motor as well. Copy this one to use the same property. Here, the screen tag, I'm going to change to motor. On the label, can use motor.id. And here we could use another property. You simplify this one, but just to use one of them. I'm going to delete all of these ones. Just use this property here just to show you quickly how it can be done. Oh, sorry. I'm sorry. Okay. So now I can save it as motor properties. All right, and then here, now we can use an action to open that screen. and then use the pointer as a parameter. So now we have this model created. You either can use it directly on the screen. Now we have a template here. Let's find the model that I just created. So you can leave it here and then set a model in position 0, for example, for this screen. Or you also can use a dashboard object that is this one that allows you insert templates during the runtime. So let's show you how it works now. This is the dashboard object. Let me clear everything. So let me insert the model as you can see here, and now can use the silo 0. I'm not sure why it's. As you can see, now I inserted one model here, and I can insert another one with another position. You can move it and resize it. And also, when you click it here or here, you see that opens the other property, the properties from each object. So this is very interesting feature that our template that can be used on this application. And also, if you want, you can export. It's going to generate a file that goes with all the images and symbols that you used on this template here. And these templates can be used in another application as well, can be imported. So you can create an import and export. You created the data types, created the screen template as I showed you. Also, you can use a dashboard object to insert it there. And I forgot to mention this these commands to save, move, or insert. You can configure it if it's the user can or not do these operations. All right. So also we have the system templates. I'm gonna get one system template. This one. As soon as I insert it here, it goes as a user template. So you also can edit it here. So change the script on tag, change that is the tag when the tag that feeds this pointer, change the value, it runs this script, and also do the changes that you need on the system templates as well. And the other interesting thing is we have a lot of system functions libraries. So we have the driver, we have many other functions, the tags. So you also can create a template that creates automatically the tags, set all the driver communication, and start communicate with the device directly without having to create a tag using our engineering environment. So this makes then this can make the templates very powerful. So now I'm going to talk about the rule-based expert system. Let me close everything. Actually, I'm going to stop this application and open another one. All right. This is where the rule-based system can be configured. Let me explain the base of the rule-based system. You can create single rules. You can create basic rule sets that are only single rules. And also you can create advanced rule sets that where you can create flowcharts and single rules. The single rule is just you can have the condition that could be like this is a default condition. It's going to check if this tag, the select identifier is different from 0. Then you are going to stop upstream machine. So you need to stop another machine because it's going to this is not working properly. And then you are going to set a tag as that is the starvation is true. Okay. So you could use logical operators, date times. This aggregate function is a really nice one because here you also can use properties and compare these properties with these sets, the aggregation functions. For example, this description our press could get from the database connection. Here is not the complete query, but you could get an average from a pressure or from the last 100 inserts, and then compare this with some properties or another entry. All right. So this is the basic rule, and also we have the facts. The facts in this case, it's a Mac that is a array of machines. As you can see here, we have let's see, machines here. You have 4 machines. So the fact, as you can see, let's add it. You can see that is. Oh, sorry. This is the plant downtimes. The name is Mac, but it's plant downtimes. The tag that's being used here. But also the types that you can have could be a database. So you can select a database and you have the columns, and the columns of each column from this table can be used as a fact. You also can read from a CSV file, and or the could use a tag on an array of tags. These factors are used as entry for the basic rules, or also for the flow charts. The flow charts, you can use rules. For the rule that was created here can be used as an entry. And also we have the conditions, the logic operators, the actions that could be known, or set a tag, run a script, send an email, or insert a message on the event, and the goal, and also a goal that could save some information on the history. If you are using assertions that is different from fact, you also can reset it when the goal is reached. And also you can monitor these rule these rules when the goal is reached as well. All right. So this is basically the idea, the overall idea of this rule-based system. Let's run this just to show you how it could work. But for example, here, if you are using a fact that could have, that in this case is an array of machines, or uh, if you use a member to check the condition, it's going to check for all the positions. So you don't need to configure one rule for each machine. So this is a generic rule that works for all the instances. All right. So for example, this is one application that's showing the OE. Here it's showing you the production, showing the downtimes. So I have a rule that's going to stop one machine if this machine was stopped. So I'm going to create a stoppage here. As you can see, this machine was stopped. Here now it's showing you that it was stopped by starvation. You probably are going to see now the OEE going down, because as you can see, the availability and the performance, we are losing those. And also here, the target, if I stop here, we are going to see the quality as well with problems. So now we have the messages that low performance and low availability is happening. And all of this were generated from here. And now here you can see we send a a message to the event, and we also send an output for the runtime log. So if I put it here to run, you see that the messages are going to our log as well. So this basically shows you how it might work, right? So if I start this, now I can start this one again. So now the availability is okay. All right. So this is the idea of the rule base, and now I'm gonna talk about what can be used like for intelligent default detection. We have a problem that we have early warning signs that, for example, the temperature is higher than the average, the vibration and the current could be defects, And if you can combine real-time tags and historical database facts, for example, and then reduce the downtime and have the predicted maintenance using here. In this case, it's just another example. You can use a motor temperature, the motor current, and the vibration. So if you have a motor bigger than 80 and the motor current and the vibration bigger than the threshold, you can create a fact, generate an alarm, and log to the database. Let's show you how you could do it in a flow chart, just quickly. You are going to have three default conditions. One, the motor temperature. So you could use here the tag, the motor. I don't have the motor here, but what machine have machines? Like this, we can use one tag, and the operator is bigger than, greater than, and here the value. So it's one condition that would be like the motor bigger than 80, for example, and then the other one, and also you can use the AND operator, so can easily connect it here and connect it here, and then you are going to have the actions that could be set a tag that will let's put the second here just to show you. One would be like the fact, a string tag you could set as a possible bearing failure, and also you can send an event. Here you can message the event that the maintenance is required, and also log to the database. So you could use here, for example, a script, and then on this script, you insert on the database information that you want. So basically, this is how you could create for this algorithm using our flowchart this rule. We also could use intelligent energy management if you have high penalties with the peak of demand charge. So we can check the tariff and how we could do it. You can use the total demand KW, it's bigger than, check the tariff is equal the peak, and then you can disable non-critical load and send a notification that could be an email, for example. And then this can be created using our root base. In this case, multi-criteria safety system. You have a single sensor alarms that cause false positives. So you can combine more information and then trigger the emergence. Not only checking the gas sensor, but checking if the room is occupied, and if the ventilation is off, then you can trigger the emergence. In a case of water treatment, if you have like pH deviations, it could have multiple calls. So in this case, you can check the pH, check the flow rate, and if the dosing pump is on, so you can possible have chemical failure. You could just use an search.
Excuse me for a minute, Leandro, let me just say real quick, we are coming up to the hour mark. If you have to drop off, feel free to drop off, but we're going to continue and finish his demonstration. So feel free. We can send you the recording afterwards, but I want to respect everyone's time. If you have to drop off, no worries. If you have questions, please submit them, okay? Leandro, please continue.
Okay, it's gonna end quickly. So it's just another, oh, sorry, another idea. If you have intelligent sequence without having a PLC changes, maybe like you cannot change modify the PLC logic or something like that. So you can also use our advanced rule set to implement the startup sequence interlocks and something like that. So you can use a startup sequence, pump start interlocks, complex logical interdependencies, and batch process. Example, the tank level is okay, the valve is open, the pump start, confirm flow, and continuous sequence. So you can use this using our flow chart. So basically, what is interesting here is you can get from an expert in a plant floor expert. He has all the knowledge that from what needs to be done in each case. So with that, this expert can draw you a flow chart like that with all the information, or just put an algorithm, and then with this flow chart, it's going to be much more easier to visualize the rules and create these rules for expert systems, right? And then talking about our roadmap that is going to improve our rule-based system, not only the rule-based, the whole SmartView, but something that can be done is, as we are going to implement machine learning functions as well in our product, the output from these machine learning methods can be used as facts. For example, if you have a anomaly score, a failure probability, a class, and a confidence, all these is gonna be can be used as a fact in our rule base. For example, if the anomaly score is bigger than something, and the pumping rule failure probability is true, then you can create the procedure. In a case that also we can have the output used as a conditional. So you can call the ML functions, for example, to predict the failure if the probability is bigger than, and so you can use the conditional. And also you can use assertions. So based on the outputs, you can create some assertions on our product as well. All right. So basically, I finished this presentation, and I hope you enjoy it. And now, if you have time, I'm going to answer the questions.
Are there any questions? If not, we can wrap up because I know we're over time and we're overseas on some of you, so it's probably very late. So if you have any questions, if we didn't answer them or something comes up, please just send us your questions either at support@adisra.com or info@adisra.com. You are available on chat. We're available on all kinds of stuff. As you know, we really do believe in customer support. It's not an afterthought. And so we really do want to hear from you. Also, if I would really recommend that you download version 4.1.5 from our website if you have not done so already. And let us know what you think. We want feedback because we're planning our next couple releases and we want to make sure that they meet your requirements as well. So please send us your feedback. Are there any questions? If not, I thank everybody. It looks like we are not. So thank everybody for your time, and we hope to hear from you soon. Take care. Bye-bye.
Bye bye, everyone.